Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping back into our 8th grade topic, geometric reflections. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. At the end of this video, I'll be putting my link to my 8th grade playlist in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. As always, if you have any questions about what you see here today, or even on homework, you can always put in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. Today's video will have 3 examples, so leave a like, smash subscribe, and let's get started. In today's video, we're going to be covering the second part of our geometric reflections topic that we first started discussing last week. Now, if you haven't seen last week's video, I recommend you check that one out before you do this one because that was part 1. We're going to be working under assumptions that you've seen that, and we're not necessarily going to recover a lot of the stuff we already talked about. If you hadn't seen it, no worries. I have a link to that video right up here. You can check it out at any time. But once again, I recommend you pause this one so you can get pretty much the basics before moving on to lines like this. Now that we've gotten that out the way, let's focus on how we can reflect over line y equals x. Now today's video, we're going to be doing y equals x and y equals negative x. And you'll see that it's a little bit different than reflecting over the x and y axis. If you recall in last week's video, there was an emphasis on keeping things eye level, whether you're going all the way across or going vertical up and down. You're going to lose that emphasis when you're talking about reflecting over lines like y equals x and y equals negative x. But you'll see what I mean in just a second. Everything else that we talked about in last week's video, we're going to be doing here to figure out what points we're going to get when we actually do reflect this. So the first thing we want to do is pick a point and let's get reflecting. So I'm going to pick the point A and we're going to try to reflect that. Now, in our previous video, we talked about keeping things eye level. However, you're going to see that that's not really possible when you're reflecting over this line here, this diagonal line here. So we're going to see what we have to do in order to properly reflect, because remember, this is supposed to be a mirror, and if this is reflecting over this line, you would expect this to show up somewhere over here, and that's going to be a big indicator why we can't simply just go all the way across. We want to reflect like a mirror. We're not going to be dropping our reflection. So A, we're going to see how far away are we from this line. This is 1, 2 away from the line on this side. So A prime, our reflection of point A, is going to have to be 2 away from this line as well. However, instead of going like this, 1, 2, and then going 1, 2, we're going to actually move up. Now, why do we move up? Remember, we just said we're reflecting over this line here. The reflection should be a mirror image, and the mirror image is going to have to show up in this quadrant, not this quadrant, this quadrant. So what we do is 1, 2, that's how far away from this line A is, and A prime is going to be going up the same amount of distance, 1, 2. So A prime is that. And you see the point A is starting to reflect over this line. So whenever you have a line like this, y equals x, and you're trying to reflect a point over it, one point at a time, you're going to have to go to the left and then up. And the reason being is you're on top of the graph here. So whenever you're on top of this graph, you're moving up. That's the only way that you're going to actually reflect properly across these quadrants. Let's do the same thing for point B. Point B is how far away from this line. This is 1, 2, 3. So we're going to go up 3. So 1, 2, 3. So this right here is going to be B prime. How about C? C is 1, 2, 3. And we want to move up now. 1, 2, 3. So this is C prime. And now we connect all the dots. Boop, boop, boop. Fill in some more dots here so you can kind of see where the dots are. And now we've reflected over this line. Now, what is this line again? This is the line y equals x. And this is our x-axis, and that is our y-axis. this is how it was going to look if you had that vertical line. You see, it's essentially how we looked at it last week. This is our line. If this was a straight line, we would be pretty much the same distance. A is from that line as A prime is from that line. However, because we're at the diagonal, we have to make sure that we're doing our two-part move and we're ending up in the quadrant that we need to end up in. So that's great and all, but let's figure out if we have a rule that we can use that we don't necessarily have to do the two-step process every time. Is there a rule we can take advantage of? Well, let's first start with our points A, B, and C, and then write what A prime, B prime, and C prime were. So A, B, and C, that's going to be, what was A? A was 1, -1. So 1, -1. B was 1, 2, -1. So 2, -1. C was 1, 1, 2. So that was 1, -2. So this is our A, B, and our C. Let's look at A prime, B prime, and C prime. A prime is going to be what? -1, 1. -1, 1. B prime was -1, 1, 2. -1, 2. And C prime was -1, -2, 1. -2, 1. Do you see anything funky happening with our A, B, and C and our A prime, B prime, and C prime? Yes, there's actually a pretty cool rule happening here that if you have a reflection over the line y equals x, all you have to do is swap your x and y. You see, our y's become our new x's and our x's become our new y's. That's true for each and every point. Our y's become our x's and our x's become our y's. Notice these signs are the same. They're preserved. It's not like we're negating anything. All we're doing is switching. So that means if you have a point P, that's x, y, and you're supposed to reflect over the line y equals x, your P prime is going to be y, x. Whatever those values are, all you have to do is swap them. And that's going to result in your reflection over the line y equals x. But let's check out the line y equals -x and see, is there a rule we have for that one? For this next example, we're going to be reflecting over the line y equals -x, and we have this trapezoid here. Now we're going to start with A, move up to B, C, and then D, and we're going to reflect this one at a time. So with A, we are 1, 2. Now previously we had to go up, but you see we're kind of cut off by this line here, and instead of going up, we really should be going down. And why is that? Well, if we're reflecting from this quadrant, the reflection really should show up in this quadrant. So moving over and then up doesn't really help us because we're going to be up here, and that's not a true reflection over this line. So using some outside knowledge on what it should probably look like, we can deduce that instead of going to the left and then up like we did for our previous example, we're going to go to the left and then down so we can end up in the proper quadrant. How far is A from this line? Well, that's going to be 1, 2. So we're going to go down 2. So 1, 2. So this is going to be our A prime. How about B? B is 1, 2, 3, 4, 5. So we're going to go 1, 2, 3, 4, 5. This is going to be our B prime. Let's do C now. C is going to be 1, 2, 3, 4, 5, 6. So we have to go down 6 now. 1, 2, 3, 4, 5, 6. So C is going to be right over here. C prime is going to be right over here. How about D? D is going to be 1, 2, 3, 4, 5. So we're going to go down 5. 1, 2, 3, 4, 5. So this is going to be our D prime. Now we just have to connect the dots. Boom, 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 boom. And we can fill in these dots here. Now forgive me, this is not a perfect graph. I try to get at least straight lines for the graph itself. Well, not the graph itself, but the axis and stuff. But this is not a perfect graph, but you get the idea of what's happening here. We reflected over this axis. Now this looks a little weird. Everything else we've been reflecting has been similar orientation, I guess, where this looks like it's starting to rotate a little bit, right? But let's look at the points and see if we did anything wrong here. So we're going to start with our A, B, C, and D. And what was A? Well, A in this case is going to be 1, 1. 1, 1. How about B? B is going to be 4, 1. So 4, 1. How about C? C was 3, 3. 3, 3. And D was 2, 3. 2, 3. Now, if we were to look at this graph, this A prime, B prime, C prime, and D prime, what would be our points? No, we don't need two A's. We don't need two A's. We need one A, B prime, C prime, and D prime. What are going to be our points? Well, A prime is -1, -1. So -1, -1. B prime was -1, -4. How about C prime? C prime was -1, 2, 3, -1, 2, 3. So this is going to be -3, -3. And D prime was 1, 2, 3. That's -3, -1, 2. So -3, -2. Now, do you see anything funny happening for this example? Yes, we have some switching happening and we have some negating happening, right? Both of those things are happening. Not only are we swapping X and Y, we're negating everything. So not just one thing gets negated, everything gets negated. So we started with 1, 1. Now you can't really see the switch there because they're both equal. However, they both get a little negative. So that's pretty obvious. Both of them are being negated. How about this one? Now you can see from 4, 1, we go to 1, 4. We're swapping X, Y, but we're not done yet. We're going to be going to negatives now. So instead of just going to 1, 4, like we did for Y equals X, we have to negate this. So our rule is if we have a point, X, Y, and we're reflecting over the line Y equals -X, our P prime is going to be -Y, -X. So for Y equals X, it was simply YX, but for Y equals -X, it's going to be -Y, -X. So don't get confused and don't forget, these are very simple shortcuts that we can use that we can easily graph whatever kind of reflection we're trying to do. But there is one question that I haven't answered or addressed in either of my two videos so far, and that is, how do you reflect a point, or let's say a graph, who has a point on the line you're reflecting over? Let's check it out with this next example. In this example, we're going to be reflecting over the line Y equals X again. However, we have a point from our graph that lies on this line of reflection. So how do we do this? How do we reflect a point that exists on the line? Well, I have good news for you. That point that's on the line, you have to do nothing with. That point serves as both A and A prime in this case. And that's always going to be true. If you have a point on the line of reflection, it doesn't change. So we can actually fill this in a little bit more, or take it away, however you want to look at it. And this is also going to be A prime on this side. And the reason being, A has no distance between itself and this line, so neither should A prime. So let's move on to B. How far is B from this line? So B is going to be 1. 1 away, so it's going to go up because this is Y equals X. We're going to be moving up. So this is going to be 1, 1. This is B. And how about C? C is 1, 2. So we're going to go up 1, 2. This is C prime, and that was a B prime. So now we connect, and you see, after connecting, this is how our reflected graph looks. It kind of looks like stairs almost, right? we have that connection point because they both are going to live on that line, and you just do what you have been doing for everything else. But now the true question is, can we use our shortcut even in this case? Is that going to affect things? Is it a special case when you have something on the line of reflection? Or is it going to work no matter what? So let's look at our rule. Remember, we said if we have a point x, y, and we're reflecting over y equals x, our p prime, our reflected point, is going to be y, x. So if a, b, and c are known to us to be, what is a? 1, 2, 1, 2. So a is 2, 2. B is 2, 1. And c is 3, 1. What about a prime, b prime, and c prime? What do we see those to be? Well, a prime is going to be the same, 2, 2. B prime is going to be 1, 2, 1, 2. And C prime is going to be 1, 3, 1, 3. So what do we have here? Is this rule still at play? If you swap x and y, do you still get 2, 2? Yes, because both of these are 2, so swapping them is going to pretty much result in nothing happening. However, both of them technically have been swapped. How about this one? B prime. 1, 2, 2, 1. It started with 2, 1. You got 1, 2. We're switching. C prime. 3, 1 is how it starts. 1, 3 is how it ends. Switching. So even if you have something on the line, you can still use this shortcut without having to worry about if this is an outlier. So I hope you're following along with the examples, and I hope you see that reflecting over the line y equals x and the line y equals negative x is going to have some differences compared to reflecting over the x-axis and the y-axis. But if you have any questions about what you see today, or even on homework, remember you can put it in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found this video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification, smash subscribe, and share this video with a friend. So that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney. Here's your playlist, and this has been another session of Tutor Me Sempai.